So, welcome to our channel Electronics on Wheel. Thank you for your support. Please like, subscribe, and comment if you like the content of this particular channel. So, thank you for your support and thank you for your request. The Rajan Singh has requested that please continue this series, and it is very useful for all. So, I am taking one another chapter, another topic in the relay, which is very useful in terms of your interview and even if you are not giving the interview, for your general knowledge that how the relay is used in the circuits. So let's continue. So in the previous video I have covered the basics of relay, where you know the what is the relay and what is the construction of relay. Then we will see the basic of this, that how they work. So you all know this is the basic circuit of the relay. So this is the low current circuit in the coil side. So here we have the coil side, this is the coil, and this is your high current circuit for which you are controlling from the low current circuit. So here you will be having some load like lamp, you might be having lamp, or you might be having some starter motor, and this is how you are controlling this. So we will see how so this is my coil and this is my contact side. So what happen when you supply the voltage on the coil, that magnetic field around this coil will be generated, and that magnetic field, what it does, it pull the hinge armature down to the contact. So what it will do, it will pull your hinge and it will create the contact. This completes the circuit. Suppose this will become like this, then it will complete the circuit, and that is how your high current circuit will be completed, and relay is set in this condition to be energized like this. Relay is set in this condition in energized, and your purpose will be fulfilled. So when voltage is removed, suppose if you have removed the voltage, then what will happen, the magnetic field will be removed from here, and that spring on the armature will pull back into its rest position. This particular contact will come again in the same position, and it breaks the circuit between the terminal. So by applying or removing the voltage on coil on low current circuit, you are controlling the high current circuit on and off. So this is the basic purpose of relay. This is what we have discussed already. So this particular condition is called as normally open. Let me just erase all this. So this particular position is called as normally open, and this particular condition is called as normally closed condition. We call it make make contact, and we call it break contact. Okay, so what we are trying to say here, if you are making the contact, then your purpose is going to fulfill, or you are controlling that particular load. When you are breaking this circuit, then your purpose will be fulfilled. So we will give some of the example where we are using the normally open relays and normally closed relay. So relay at rest, this condition is called at relay at rest, and this condition is called at relay is energized. So moving further, we will see all these in detail. So first we will see the relay terminology. So we will take one example of ISO mini relay, where you will have the 4 pole. So already I have told you that 85, 86, and 30, and your 87. So if you have the 4 pole relay, it would be like this. Okay, so we will try to understand which side should be 85, which side should be 86. We will see this thing in the coming slides, and why it should be like this. 30 and 87, we will see this thing also, why we are giving the terminal name like 85, 86, why we cannot give 22, 23, 24, 25, 6. So we will see all these things. So this is a 4 pin relay, and the structure would be like this. So mini relay, as I told you, that make or break relay we call it, because there is a one high current circuit, and the contact in either open or closed, either open or closed, depending upon whether relay is at rest or energized. When it is rest, it is normally open. When it is energized, then we call as normally closed. If contact is broken with the relay at rest, at this condition, then it is referred as normally open. If it is contact is closed with relay at rest, then relay is referred as normally closed. So normally open relay mostly used in the automotive, we will see, and other applications also. Why normally open only we are using, why we cannot use the other. So these normally open and normally closed, these are the two operation, and we call it make and break, as I already told you. Then we have the 5-pin relay, where you have one particular other logic you can refer as. So explain you. So there is a 86 and 85. Here we have the coil. Then you have the 87 and 87A. This would be the 30. So 30 would be the common. So two circuit, one which will closed when the relay is at rest. So when relay is at rest, it would be a closed circuit here, and other which is closed when relay is energized, have a 5 pin on the body and referred as a changeover relay. These have two contacts basically to a common terminal. So this is one contact and this is the other contact. So whenever you have the 5 pin relay, you will be having the two contacts, and in this condition you can put the logical function in this also. That's why we call it changeover relay. We will see it in detail how and when you should use. So make and break relay is also known as a single pole single throw. Means single pole single throw means if you will be having only the contact, only single contact, then it call as single pole single throw. But if you have the single pole like this single poles, let me erase this, then you will come to know. So this is my single pole, but double throw. Like you can throw that particular contact either this side also and this side also. So in this case, it is called as single pole double throw. So SPST and SPDT, you might have listened, heard this terminology many times. This is based on the standard switching terminology. So there is a terminology. These are the standard terminology by which we are saying this is a single pole single throw and single pole double throw. And even the naming of this also, it is as per standard. We will see what standard we are using for giving this name. So there are other contact configuration also we will see based on this, but the concept will remain same, that normally open and normally close and changeover. So this particular condition, so one side would be relay, this sorry one side would be, this is the coil, and other side would be your contact side. So if you are having the normally open relay, that you having this SPST, that is called single pole single throw. But when you having the two contacts here, one is normally this condition, it is called as normally closed, and it will be called as normally open, then it is a single pole double throw. When we will have the double pole single throw. So you will be having here two contacts, and you will be having the normally open and normally open 1 and normally open 2. This is also one configuration which you can make. Then we have the double pole double throw. So two poles, we having two poles like this, but we having a double throw. So two times we can throw. Here we were throwing only one times this contact, either this, it can become normally, see here it is normally open. So either you can take here like this and here like this. That is the only configuration you can make in this, and other than this you cannot make. But here if you see, you have the normally closed one position and other one is the normally open. Here also you have one normally closed and other one is normally open. So here you can make the four logics here on this condition, double pole double throw. So these are the possible configuration which you can make out of relay, and these are SPST, SPDT, DPST, DPDT. But the concept would be remain same, make and break. As I told you, make means normally open, this is normally closed, and other one is the changeover relay. Changeover relay is this means that you can have the two type of situation where you can throw your contact either normally open or normally closed. Let's move to the terminal numbering. So I told you earlier also that why we are giving this 85, 86, 87, 87A, 30, why we cannot give as 23, 20. So there is already one standard which we are following for the terminal numbering on a relay body, that is called is DIN 72552. This you please remember when you are going for the interview or other things, then it will become handy. Sometimes interviewer ask if you are working on relay. So which is German automotive industry standard and widely adopted and allocates numeric code to various type of electrical terminals found in vehicle. So it is not only for relay, there are other standards also where you other components also where you can you will be having these numbering on that. So for uh, 4 pin or 5 pin, for 5 pin you will be using 87A, that is the extra one, and for 4 pin you will not be having. So 85 and 86 for the coil side. So that's why I was keeping, if you see here on this I was keeping 85 and 86 on this side and 87 and 30 in this side. Now which one we should have to keep here, 85 and 86, we will see that also with logic. So this is the coil side, and this 87 is normally open and 30 is a common connection to NO and NC terminals. This particular 87A will be present only in the 5 pin relay, not in the 4 pin relay. So this is the terminal numbering. I will show you some of the terminal numbering for other component as per DIN standard. So I will share this particular DIN standard in the Telegram. You can join the Telegram and you can find out that particular file. So where you have the different terminal numbering for the different components. So let me show you that particular document. This is the DIN 72552, that is the terminal designation and that defines. So I'll show you, you can get this particular document in the Google as well, but I can give you through the Telegram. If you want to join, you can join and you can download from there as well. So suppose if you are using for the battery, this is your battery. So for 15 we are using for battery plus through ignition switch. For 30 direct battery if you are using, then 30 is second battery 12 or 24 volt relay. Then return path के लिए for return path we are using 31. For return to battery 20 or 12 volt relay, then 31A. 31B return to battery negative or ground through switch, or 31C return to battery relay electric motors. So these are the defined terminals which are used across the automobile industry, and you should remember these terminals. Why you should remember? Because suppose if you want to give the particular connection from direct battery, then you should not use the terminal number 15, you should use always 30. If you are giving the particular connection through the ignition switch, then you should give the 15, you should not give the 30. Okay, so this thing you have to remember. So you here you can see for other particular systems also, like ignition system, preheat, diesel engine, electric motor also. Then you can see for the turn lights, flashers, generator, voltage regulator as well, dynamo, then AC generators, lights, acoustic warning, switches, then windows, relay. So you can see here relay also. So for 85 relay coil minus and 86 relay coil plus. So I will tell you when it matters relay plus and relay minus. I will tell you some of the situation we will take, and then we will try to explain that when it matters, that either we can swap the terminals here, or we can keep those terminals as it is. But as of now you just remember that relay coil minus would be 85, relay coil plus would be 86. So moving to our I have explained you about this terminal configuration. What is DIN 72552? The coil should be fed with plus 12 volt to the terminal 86, as I have told you in the DIN 72552 document also, that plus should be on terminal 86 and grounded via terminal 85. However, in practice it makes no difference which way around they are wired. I will show you this type of condition, that why coil will not be a problem. But when you using the coil along with some diode or some resistance, some diode, then it matters. So I will tell you some of the situation when you are using your relay with along with diode, then it matters that you have to keep 86 on the positive side and 85 on the negative side, coil minus and coil plus. But as of now, if you are using the relay without any diode, then you can use it anyway. Either 85 you can keep this side and 86 you can keep this side, this terminal. There is no difference. Okay, when it will be integrated with diode, then it matters, because you know forward bias and reverse bias. We will take some of these cases. In this case, you can use the changeover relay in place of make and break relay by just leaving either NO or NC terminal disconnected. Okay, so what does it mean? So we have the 5 pin relay, suppose, right? So suppose if you are not using this particular contact, then it becomes a 4 pin relay. So you are not supposed to use that particular 4 pin relay. Suppose you have the relay base of 5 pin. Okay, 5 pin relay. Suppose you have one relay base where you can use your 5 pin relay only, and you have the requirement of using the 4 pin relay, correct? So it doesn't matter that you should go with the 4 pin relay only. You can go with the 5 pin relay also. You should not use this connection. That's it. 87A. Let's move to the terminal layout. So in 5 pin relay, there are two types of terminal, type A relay and type B relay. So here if you see 87 and 86, 85, sorry, 30 and 85. So this would be the type A relay, uh, and this would be the type B relay. So always you will notice that type B relay pin 86 and 30 are swapped. If you see 86 and 30, 86 is here and 30 is here. Or compare the type A relay layout. If you see in the type A layout, then this terminal 30 is here and 86 is here. If you see here type B, that 86 is here and 30 is here. Type B layout is arguably easier to work with as connected terminals are inline. So making the wiring easy to visualize. If you need to replace a relay, make sure you use one with the same terminal layout, as it is easy to overlook. So what does it mean? I will show you in the normal language. So you remember we have the this structure of the relay. So if you are using this type B relay layout, okay, so you will be having here 85 and here 86. So if you compare by this, that 85 and 86 are opposite to each other. Can you see here in type B relay? This is opposite to each other, right? So it will be easier to visualize that this is my coil connection, this is my contact connection, 87 and 30. 87 and 30 is my contact connection. So it is very easy when you are following the type B relay. But in this you might be confusing, like 87 is my contact or 86 is my coil. It will be confusing. I will show you some of the relay representation where you will understand. So this is my, if I ask you 87 and 30, so you can directly tell this 87 and 30 is my contact, and this 86 and 85 is my coil. And one more thing you can do here, whenever you see these terminals, so always the coil terminal will be in the same direction. If you see the direction of this here, but contact terminal all most of the time would be in the bigger in the size. First thing, because they are carrying the high current. Second thing, they will be in the opposite. So this looks like this, but this is coming as a horizontal, this is coming as a vertical. You remember this thing, when you are taking any relay in your hand and someone asks you to find out the relay coil and terminal side, then it will be very easy to find out this thing. I hope you understand my point. If we still did not get what I'm trying to tell here, please comment. I will try to explain again. And these are the marking that normally open what is the current carrying, then normally close what is the current, and what is the rating of this particular relay. So this is how you will get the, this is the picture of actual relay, where you will be having the marking 87, 30, and this uh, 86, 85. Terminal sizes, so terminal size also varies as per the requirement of relays and capacity of that relay. So width of 4 pin and 5 pin relay almost always like 6.3 mm wide, 6.3 mm wide. So you can see here, this is the width of the terminal. However, some more specialist relay can have terminal width of 2.8, 4.8, 9.5. So as I already told you, it depends on the power capacity and type of relay. But most of the time you will get the 6.3 mm wide terminal width of that particular relay. 9.5 mm wide terminal tend to use for the high power application, as you have the for starter motor solenoid activation, you have the high current requirement, and you have to control high current for that particular load. You know that in starter motor we have the peak value around 700 amps, okay, and 600 amps, depends on the capacity of the starter motor, which kilowatt of starter motor you are using, 2 kilowatt, 3 kilowatt, 3.5 kilowatt. So it depends always the peak current also on the kilowatt, but it ranges in the 700 amps or 600 amps, in that range. So in that type of situation you have to use the uh, bigger width of terminal, that is like 9.5 mm. The smaller terminal tend to use for electronic signals where you have only very low current required. So for the like ECUs, you can use the low current relays where you do not require the higher current requirement. So all widths are compatible with the standard flat corresponding the size. So this is I have just given one example where you can see the dimension of the relay in the data sheet of the relay. So different relay have different here you can see I have given this example also, 9.5 mm also you have, 6.3 also you have here. So this is all about relay. Let's move to the after terminal size. Let's move to the relay body marking. Okay, so relay body marking, as already I have told you. So relay body marking looks like this. So relay can look very similar from outside. So they can normally have the circuit schematic, voltage rating, current rating, terminal number marking. So already shown you the circuit schematic. Also it shows like this, that which we have already made. The one side would be the coil side and other side would be the contact side. So there you will be having this schematic circuit and the marking also like 85, 86, and 30 and 87. So this marking also will be having. Then voltage rating. So typically for passenger vehicle we will be having 12 volt, and for the commercial vehicle we will be having 24, like this you can see here. And 6 volt also for older vehicles, but as of now we are not using 6 volt, we are mostly using the 12 volt and 24 volt. Then current rating. So current rating also you will be having in different current ratings, normally between 25 to 40 amps. However, it is sometimes dual rating for changeover relay. So 30 and 40 amps also, as I told you, there are two contacts in that. So 30 and 40 amps also it can handle. So here you can see that normally opens 80 and 60, you can see here. In case of dual routing, normally closed relay is the lower of the two. So if you see here, let me erase, then only you can see. So if you see here, this is my normally closed, so this is a changeover relay here. And you see here it is 60 amps, but normally open is having the 80 amps of current rating. So suppose sometimes if you get this type of rating on your relay, then you understand that this is a changeover relay, and 30 amps for the NC normally close, and 40 amps for the normally open. So here also we have shown you that this is a like 80 amps of relay, where for 80 amps is for the normally open, 60 amps for the normally close, and this is for the 24 volt for the commercial vehicles. Current draws for the coil is not normally shown, but it is typically in the range of 150 and 200 milliampere with corresponding coil resistance around 80 to 60 watt. So the one side, so as I already told you, this would be my contact side, this would be my coil side. So coil side current requirement would be in milliampere, like 150 to 200 milliampere. But when it contact side, this rating, whatever rating is given, 30 amps or 40 amps, this rating is given on a contact side. So 30 amps and 40 amps is given for the load which you are controlling, that how much load you can control by this relay. Okay, so I think this might be clear for you. Knowing the coil resistance is useful when testing a relay for a fault with a multimeter. A very high resistance or open circuit reading can be indicated damage of coil. So suppose resistance of that particular relay is uh, is very high. Okay, so what does it mean? That that particular relay coil is damaged. So that's why this ratings of the component and ratings of the coil side and contact side is necessary when you are diagnose your fault in the vehicle. So that's all. I will cover other points also. So we have many other points where I will show you that what are the different types of condition we can use in the relay. And I have written one article already. You can please check that article, and there we have shown some of the cases also. So let me take you through that article, and you website electronicsonwheels.com. So where we have written why I want to use the relay. So here you can check this particular article where we have written what is the use of relay, why we are using construction of relay, how they work, then relay terminology, all the things, then body marking. And then next topic which I am going to explain you, these are the different configuration, like make and break relay, changeover relay, relay with double output, relay with dual contact, relay with integrated fuse, relay with diode across the coil, relay with resistor across the coil, what is the micro relay. Then more complex relay type, glow relay, fuel injection relay, timer relay, flasher relay, how they are used in the adding a buzzer with that warns when you are left with headlights. So all these things we are going to discuss. If you like the this video, please leave the comment on this website. It will be very helpful for us to get to know that whether it is helping you. Many of you have requested us that please give us the content. So we have find out this way that okay, you can go through our website and you can get all the content which we are, you know, creating the video for that. And yeah, That's all. Thank you for your support. If you like the content of this channel and website, please comment, and thank you for your